needs to be at least 9 to be able to charge the LiPo batteries, because you want to charge them up to like 8.4 volts. So you need at least 9 to be able to do any charging. And then you can go up to 18 without any problems. I just recommend using 12 volts. The motor drivers, one of the common things, I think one of the things that was a hurdle for some of the Scuttle folks initially was trying to power everything off of that DC input jack to run the motors. It's not designed for that. It's a charger circuit. It's meant to charge a battery. The pull for running the motors is the battery. So you're just happen to be running off of the charging voltage, not a regulated supply for running running the motors.
Our H-bridge outputs go to a bigger H-bridge, and so we're only sending signal level current to the motors. That's no problem. But upon driving a servo, like a hobby servo on this rail, that's when we had a problem. Okay. So if we do one, it's interesting because
go ahead.
When we plug in one, it has full torque, or at least it feels like it does at full speed. You plug in a second one, and they both start twitching out of control.
You plug in more, and it might even work better because now it's going to be trying to drive the charge more often. But it's going to be irregular because the voltage output is from a charger circuit that's expecting a battery to be on the other end. So it's going to try to push voltage in there to charge a battery, and then it's going to get really confused when it doesn't see the voltage come back. Right? It's not sustaining any charge. It looks really weird to the IC.
To the charger, yeah,
to the charger IC. And so what you can do to run off of a bigger battery or just directly is between the opposite side, between the ground and the VBAT signal, you can just connect a voltage there, and that will go to the motors, right? To a 6-volt regulator for the servos, or to the directly to the DC motors.
You're saying, so there's 3 pins on the LiPo.
There's 3 pins on the LiPo. You don't need the center one because that's the balance pin between the 2 cells.
I thought you were supposed to have a one LiPo cell voltage difference between 0 to middle and first to middle and middle to final.
There's nothing checking that.
Oh, okay, great.
So that for charging and for balancing.
Yeah.
So the if the balance circuit can cut off the whole supply, there's a balancing. Where's the balancer? So the balancer here can disable the charge enable, right? But it's not going to short circuit VBAT or disconnect the circuit on VBAT. Does that make sense?
If we put 12 volts, or that's too much. Is that gonna break it if we do 12 volts on the third pin on the LiPo connector?
The third is
so if we on our LiPo connector, if we hook up 0 to ground and a 12 volt source to the third VBAT. And that's the third pin, or that's
the third pin. There's
okay.
VBAT, there's VMID,
okay,
and there's ground.
And is 12 volts too much? Will it break it?
Or BAT mid. So it's VBAT, BAT mid, and it's called BAT minus. Okay. But that's essentially ground.
And
the DO, so this the connection to ground is opened. Okay, so you might need a BAT mid because this protection circuit has the ability to cut off the connection to ground. I don't know what circumstance that is though.
can we try it? After 3
Yeah, let's try it. I've seen people do it, so I'm just saying with confidence that it can be done.
Yeah.
But the circuit gives me a little less confidence because I don't. What this protection does. That I need to look at what this circuit does. When does it drive DO so that there's a connection to ground?
Okay.
of course, the balancer is not gonna have any issue, and the charger is not gonna have any issue.
If you put a capacitor in place of each cell,
I worry.
You put two caps.
Yep.
So there's 3 terminals, and you plug that in. Would the circuit maintain a battery voltage charge on the capacitor?
You'd have to look at the charge IC.
Okay.
It sounds reasonable, but the charge IC might detect something.
Might get mad.
And make it mad.
If it swings too fast,
It might say that's not safe. It might determine, because this is essentially a microcontroller, right? All right. Anyway, you can real time kind of catch what those what the battery, like you can actually get that feedback using the test ADC. Of course, there's C APIs for all of these as well, and you can look at those actually in these example files. There's a template, this RC project template, that if you want to make one of the C programs, that you essentially, here's the make file, here's the C file, to make one of these librobot control files to begin with. It's under opt source, librobot control. And I think and then RC project template. It's not under the
Go
examples.
ahead, double click it.
This is the project template source file, and then the make file is here. I'm not going to go into the details of make files or C.
That's the next thing. We've never, or at least I and the students under my instruction, never ran a C file directly on the Beagle. And it sounds like it's pretty easy.
Yeah. The performance is a whole lot nicer.
No, that sounds great, because I'm comfortable with C. And also, I think, if I understand, we can go grab C libraries that will do stuff.
Yep.
Put it in a directory and run it.
Yep. I've got a. If anybody has a pair of pliers,
Yep.
just for demo. I didn't.
What do you actually want? You know what pliers?
What's that?
What?
Pliers.
Where's it?
I just need something to be able to turn this motor. My fingers
Okay, yeah.
aren't strong enough.
Do we have a spare gear?
For you guys, Sarah's your friend. There's only 3 of those. We talked about the gray code encoders, right? There's only 3 of them on the board. The 4th one is actually implemented in PRU software. Trying to find an elegant solution. So right now, the permissions to communicate with the PRUs require root access, so you have to do sudo. Anyway, let's see if I can turn it with my fingers. I'm just not strong enough. Come on, motor, turn.
I think that one's really high gear ratios.
Yeah.
The reason we had done
It's 26 to 1.
Yeah.
And it did
How many RPM does it call itself?
There it goes.
Yeah, I don't know why it's messing up.
So I guess let's
going.
just try to see what one rotation is. Let's put it in one spot. Zero it out here. Come on. So about there to, let's see, 180, and that should be about 360. So there's about 700 pulses per revolution, somewhere in that ballpark. As far as how far does this go before our counter overlaps? You see, every time I start this program, it's going to essentially clear the counter, right? I know it's at least 16-bit, if not 32-bit.
Wait, and you've done more than one rotation on the.
Yeah, 700 was one rotation.
Oh, that's because, yeah, because of the gear reduction. So you're just gonna go like 26 times?
So, anyway, a lot of rotations.
Yeah.
So I think that as long as you read it often enough, you know, you're reading more than, I mean, if you're getting entire rotations and you haven't read it, you're not reading it often enough. So you can rotate it 10, 20, 30 times and still be able to, you know, if you haven't read it, you still have time. So that one's that. So there's encoders on these MIPS. You able to run that okay? Yeah, those wheels on there have encoders, so
We'll just unplug an encoder from MIP.
and plug it into your Blue.
Plug it into
Well, that's why, I mean, because I'm doing one without a MIP. That's why I went and grabbed this motor, because I just wanted to make sure that this is the motor you guys were planning to use. I just wanted to make sure that
Actually,
Yeah.
oh wait, just encoders. Yeah, we can do it here.
So number 4 is kind of the oddball one. That's actually that's a PRU software that's reading the pulses rather than an actual hardware encoder.
Are you sure?
So I haven't gotten to the Python example. I really haven't even touched the examples folder, so I'm probably about 15 minutes behind where I was thinking. There's a whole bunch of examples in here that we can just kind of do the same thing in Python. Examples, Blue. So those were the pre-compiled C examples, right? The RC underscore.
Wait, so
And things like test motors, right? It provides some arguments where you specify the duty. And using these built-in command line tools is a really fantastic way just to test your hardware out real quick. Like, okay, can I just do this and watch the motor spin? Hardware's good. Now it's all programmatic problems, right?
So where's the file, the C file that runs when I do RC test motors?
The source. So realize it's pre-compiled and it's like, so which is your friend? RC tests motors, right? So it's using in user bin that program, right? But that's not where the source is, right? That's the compiled output that's pre-installed. The source for RC test motors or RC test encoders is under librobot control examples source RC test. I think we're looking at encoders, right?
Right here. Source.
I can't believe you've made it this far without seeing this stuff. That's
Well, no, we didn't have any resource. We just had to. We just wanted this initial walkthrough. We're a year in.
Although I think I found out on the kit, not on Beaglebone.
Yeah. Because this is the documentation of all that, right? So the examples, the APIs, right? So you've got all these different APIs that kind of help you out. The IMU API, the motor API.
What is model? 2 items up.
Oh,
Model T.
that's just for like board type. So this is probably
Oh,
just some helper functions he has in here to run on Beaglebone Black Wireless, or Blue. But the RCPY stuff, there's a bunch of examples in here.
Yeah, okay,
So like if I want to run, so I'm plugging into 2. The silk screen for the numbers is really small. It's to the left of the motors, and it goes in this clockwise pattern from lower to left. So it goes, it's 1, 2, 3, 4. All right, so it's 1, 2, 3, 4 on here. So lower left, top right, bottom right. So this is the 1, 2, 3, 4 is the orientation. There is silk screen that shows the numbers, but you probably won't see it unless you get a magnifying lens out. Your eyes are a lot better than mine.